Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Ikhmal bin Jamali. My supervisor is Prof. Major TS Dr. Surayani binti Adnan. And then I'm representing from Faculty of Engineering Technology in Civil Construction for my final year project 2. My title of project is Performance of Beam Containing Bamboo Ash in Concrete Mixture. I will start from the introduction of my presentation. So bamboo is the most commonly available material in Malaysia. The type of bamboo that have been used has an effect of the final result of my study. Additionally, it is dependent on the pozzolanic and cementitious characteristic of bamboo. The selected type of bamboo that called Bambusa vulgaris due to for easier bamboo waste can be found. Generally, all the sources of crop residue come from any industry that mainly use bamboo as a product. Generally, for my final year project, this study, the introduction of bamboo ash, which was originally a crop residue, has been innovated in a finer form. Bamboo ash is used to substitute for cement according to the percentage rate of 5%, 10%, 15%, and 20%. Before the material was used in ASTM scanning electron microscope, X-ray fluorescent XRF, and the particle size analysis by SILAS that will be tested before the bamboo ash will be used. The compressive test and the flexural test was used in the main test. Bamboo ash, or better known as bamboo ash cement replacement (BACR), will act mixed using DOE mixed method design with the ratio of cement, fine aggregate and coarse aggregate is 1:4 respectively. From what you see at table 1.0 shows a summary on how the division of concrete material according to the design. This objective for the study are to determine the compressive strength of concrete containing bamboo ash and to determine the flexural strength of concrete that a little bit part for literature review. So I will be focused on the bamboo ash characteristic following the normal scale of Portland cement and used in the mixing. Only the fine bamboo ash going through the sieve was obtained. The specific gravity was 2.05. It's written by David Hassan in 2018. And then the compressive strength or pressure phase analysis by XR diffraction, which is XRF, functional group analysis by Fourier transform, infrared spectroscopy, and microstructure analysis by scanning electron microscopy are all used to characterize the geopolymer. And then the primary component was potassium oxide 32.23%, and then the silicon dioxide 24.32%, and then the sulfide ion, which is consists 14%, and then the oxo calcium 3.99%, and then that will also present a little bit a level of 6.6% of magnesium oxide. Some of the species of the bamboo have a tensile strength until reach to 600 megapascal, and for the single bamboo fiber have a potential to achieve tensile to 2000 megapascal. And then bamboo production of biomass and the ability of sustainable managed bamboo plantation to regenerate themselves are undoubtedly important feature. Bamboo seed or Bambusoidae family, it is made up of cellulose fiber embedded in geometric. Because of its high tensile strength to weight ratio, it is commonly used as a scaffolding, wall proportioning. Many successful studies have been performed, showcasing a wide range of bamboo construction application. So in my study, I'll be transform the bamboo characteristic to be an ash to replace the cement. For this study methodology, based on the flowchart, I will start from recognize the problem to improvise the performance of beam, and then I got a few research that related to my final year project, and then I will design the mixture of concrete, which is I have decided to use DOE mix method, and then I will prepare the sample, and then each of the sample and the material will be sieved according to the design, and then I'll start mixing, and then I'll doing for the workability of concrete, which is by using some tests, and then will be next molding and curing, and then I will be tested for compressive and flexural. So from that I will be analyze the data which is approved or not. I will make a discussion to conclude my study. So I will explain on how the process of bamboo ash briefly. It starts from the remaining used part of the bamboo that will be burned in a furnace with a temperature around 600 to 700 degrees Celsius for 6 hours, and then the material is still in pre-treatment phase, where it's not been yet used as a substitute for cement replacement in manufacture of for concrete. It's continue process the raw material in the laboratory. Before undergoing the next process, the material was placed in a tray that fit the size of the oven, because it's required for the process of drying material around 150 to 300 degrees Celsius for at least 1 hour. The machine can grind raw material from the bamboo to produce the ash with a size of less than 45 micrometer, and then the material was processed by using a ball mill planetary machine at speed 350 RPM for every 10 minutes. It will be prepared 100 gram per set. After that, it has been isolated into the airtight plastic to ensure that it's always dry and not mixed in with foreign matter. So the bamboo ash cement replacement, called BACR, recognized by the color that is black to gray ashes, and then the size of the bamboo ash by passing through sieve less than 45 micrometer, and then before we are declare the bamboo ash is ready to use as a cement replacement. 3 type of testing to verify the characteristic of bamboo ash, which is the first one is ASTM test, the element to ensure the element content inside the bamboo ash, and then the XRF test to count the percentage of chemical composition, and then the last one, verification test, is size particle analysis by SILAS. For the failure, the mixing method and mix the concrete material will cause the slump test result will be affected, as well as the compressive strength after 7 days and 28 days. All slump and compressive strength tests before the verification and concrete manufacture of reinforcement concrete beam flexural test. So there have 2 type of sample that we have been used, which is the first one is cube size with 100 millimeter per cubic, and then the beam size with span length is 1 meter times 150 for height and 150 millimeter for width. For the result, I'll start from the verification test. In general, by SCM, it can be claimed that bamboo ash has a similarity in the proportion of atomic weight element with ordinary Portland cement. The description of the element can be seen through the figure, and then which is the morphology of bamboo ash by SCM when detecting the particle size at size of 25 micrometer. As for the proportion of chemical composition, silica of bamboo ash has a value 3% greater than the Portland cement typically used in the building construction material. It was tested result by XRF, and then this can indicate the pre-study for element detail, chemical composition, and the particle size verifies that bamboo ash has a pozzolana capabilities for concrete replace material of cement. Plus, particle size analyzer by SILAS also prove the majority size particle of bamboo ash maximized on 45 micrometer processed by planetary ball mill. Through the analysis, the maximum particle size for 45 micrometer reached till 94.33% cumulative percentage Q3, and the amount for the differential distribution as much 2.98%. This show the most of the bamboo ash sample have reached the desired particle size of 45 micrometer. The particle size for bamboo ash is all below 100 micrometer. While the compression test is shown in figure by using the bar chart. At day 7, maturity BACR5 measure 26.72 megapascal, while the control sample measure 24.11 megapascal. Compressive strength should reach 65% of the objective in 7 days or 30 megapascal. The statistics show that only the control sample and BACR5 achieve 65% strength. BACR10 compressive strength dropped to 16.93 megapascal, whereas BACR15 was 13.60 megapascal. Comparatively, BACR20 has a higher data for 28 days. As shown in figure 3.5 for flexural strength test result, it's behaved similarly to a graph plot when it's display a linear form. Essentially, this study will determine the ideal quantity of bamboo ash to utilize in order to achieve a load almost comparable to that of the standard concrete. While this data is not exact, that it demonstrates the relevant bamboo ash is utilized as a replacement for cement. The graph depicts a decreasing plot. Nevertheless, PSCR5 is the closest since it has the least different and comparable to the control sample performance. For the conclusion, the bamboo ash in concrete as a substitute for cement has the potential to significantly reduce greenhouse emission by boosting the possibility of obtaining a greater number of carbon credits. To test a sustainable of bamboo ash as a partial replacement for cement, for reinforcement concrete beam, the appropriateness of bamboo ash as cementitious material was determined by conducting the compressive and flexural strength tests on the concrete. According to the analysis of the concrete qualities, the optimal percentage of bamboo ash in cement was 5%, which is BACR5 in terms of compressive and flexural strength test. For the recommendation of my study, a bigger grinding machine should be available throughout the grinding process to enable the preparation of more sample in less time. Grinding using a planetary ball mill equipment is only possible with amount of raw material of bamboo ash weighing between 90 gram to 100 gram. As a result, the study drawback is more time is required to make bamboo ash. Standard additional value may be gained by utilizing larger grinding machine.